Alright guys, so we're back with our second video in our surface area series. Today we're going to talk about cylinders and cones. So since we kind of had a little intro in the last video, the comprehension and understanding of this hopefully setting in. So when I start talking about nets and bases and faces, we should be good to go, right? I don't have to spend too much time explaining what all of those are. So a cylinder differs from a prism in that the bases are now circles, okay? So a 3D figure with oval or circle bases, and there's actually only going to be one face or side, and that side is parallel to our bases, right? So here's kind of what a cylinder looks like. We've got our two bases that are always going to be circles. For us, it's going to be circles. We'll never use ovals. And then you have your lateral face. Now think about a soup can, right? When you have a can, if I was to peel off that label, right, there aren't any edges, right? There's no like hard lines like in a prism. It's just a continuous roll. But when I unroll it, or I think of a paper towel, what shape does that make, right? And hopefully you're thinking to yourself, rectangle, okay? So the surface area formula is very similar to a prism because they have top and bottom bases, and they do have a face, right? The difference now is instead of dealing with a polygon where there's sharp edges, it's just a circle. And so let's take a look at the net, right, of a cylinder. So as you can see, right, we got our two bases showing up here and here, but then here's that paper towel or that soup can label I was talking about. So even though it's rounded when it's wrapped around our cylinder, if we unravel it and lay it flat, all it is just a rectangle, right? And so the important part to note is that this distance here and here in yellow, that is the height of our cylinder, and that would be this distance here and here, or it's the same, okay? And then the other thing important to note is that this distance here that wraps around the cylinder is the same length as the circumference of our circle, okay? So we're still going to have bases, so capital B. We're now going to introduce C into our formula, and we still have height. So C is pretty much taking the place of P because circles don't have perimeters, they have circumference, okay? So our formula for the surface area of our cylinder is 2B plus CH. And again, the 2B, that is the surface area of our bases. And then the CH, that's going to be the surface area of that lateral face, right? That rectangle, that soup label, that paper towel, when it gets laid flat, is a rectangle. So let's do a quick example. We'll do two quick examples, then we'll get to cones. So when I look at this cylinder, the top base, which is the same size as the bottom base, has a radius of 4, right? And so to find my area of my base, that's just pi r squared. Let's get that decimal amount. So 4 squared is 16. 16 times 3.14 is 50.24. Okay? Next, we need our circumference. So actually, let's throw our height in there. We know our height, distance from circle to circle or base to base, is 7. And then our circumference, again, our circumference is going to be kind of like our width or our base of our rectangle that is in our net diagram. Okay, that's going to be 2 pi r. So 2 times pi times my radius, which is 4. So 2 times 4 is 8. 8 times 3.14 is 25.12. So then our surface area is 2 times 50.24 plus circumference 25.12 times my height. And then just got to use our calculator. So 50.24 times 2 is 100.48. And then 25.12 times 7 is 175.84. Let's add those two together. So 175.84 plus 100.48 gets us 276 0.32 inches squared. And again, remember surface area, if I were to paint a cylinder, it's all the parts that I would need to paint. Okay? Pause it for a second, give that one a try, and then come back. Okay, I'm going to go ahead and copy this diagram and then go to a new page because there just wasn't enough work or enough space. So let's think about what we know. I know my height is 20. My area is going to be pi r squared. Don't use the diameter as the radius. Okay, so 16 divided by 2. So 64 times 3.14 gets me 200.96. And then my circumference would be 2 pi times my radius. So 16 times 3.14 gets me 50.24. So then our surface area formula, 2 times the area of one of my bases plus circumference times my height. So 50.24. Like we just used that number, didn't we? Weird. Okay. 50.24 times 20 is 1,004.8. And then 200.96 times 2 is 401.92. Go ahead and add these two amounts together. And I get 1,406.72 feet squared. And guys, surface area is big numbers, right? It's a lot of space being covered up. So you should most of the time be getting something pretty large as far as your answer goes. Okay. So that covers cylinders. Again, cylinders are pretty easy because there's not anything super funky about them. You just have your two circles on the top and the bottom, and then that rectangular face that goes around. Okay. So now let's get into cones. So a cone, right, is a three-to-figure with one base and one face that ends in a point, or this guy right here. So this is our first entry point to where there's no longer two bases, there's only one. All right? And so now think about how our formulas have been constructed, right? It's always been area of the bases plus area of the lateral faces. So our formula for this is going to be very similar. We're going to have the area of the bottom, or this part down here, plus the area that goes around as the cone goes up into that point. So let's look at a net diagram of a cone. And so a net diagram of a cone is kind of funky, right? Like this is pretty self-explanatory, but that lateral face, when it's unwound like this, it's almost like it's a sector of a circle, right? Where these are radii, and this is our arc of our circle, right? But luckily, we don't have to use anything regarding arc measure or anything like that, because this sector, this sector with measurement arc length x, so meaning arc length x and radius y, has the same area as a triangle with base x and height y. Okay? So I'll say this one more time. The sector of a circle with sector arc measure of x and radius y has the same area as a triangle with base x and height y. So like if x was 10 and y was 8, those two figures would have the exact same area. So that makes it nice because we can simplify the second part of our formula to use the formula for area of a triangle and not have to worry about area of a sector, which, trust me, is way easier. So as I said, we still have base area. What's new is slant height. So slant height is that this guy right here, but it's this distance on your cone. So it's the distance from the edge of the circle to the vertex point of the cone. Now when we get to volume, we'll start talking about this distance right here. Can't really seem to draw a straight line. Where it's the distance from the center of the cone up to the vertex. That's the actual height of a cone. But for surface area, we use slant height. So the slant height, again, is that yellow part on the cone that I just shaded in. And then the last thing we need is circumference. The reason we need circumference, right, is to get this. If you look at the net diagram, the circumference is this part here, or when we're looking at our diagram, it's that arc measure, or excuse me, arc length, or it's that base. It's all the same. Okay. So now for our surface area formula, we only have one b, so it's just b plus, and then the area of this would be. So again, I said that the x is kind of like your circumference, right? So it'd be, and if it's a triangle, so the area of this triangle, right, and that y is like your slant height, it's going to be 1/2 base, which is circumference, times height, which is slant height. But since the formula for circumference is 2 pi r, we can simplify this part into pi rl, because if I were to do this 1/2 2 pi rl, the 1/2 and the 2 cross each other off, so we can just simplify it to pi rl. So this is the formula you're going to want to remember for surface area of a cone. And just also remember that the first part is your area of your base, and the second part is the area of your lateral face. Let's do 2 examples, and then we'll be done. Okay, so again, there's our formula just for a reminder. So here's our cone, right? So the first thing I want to do is, okay, well, I know my slant height's 10. That makes our life easier. They give it to us. And then I can find my area. So b equals pi r squared. So that's going to be 16 times 3.14. I got to stop using the number 4. 50.24 again. Okay? And then we have pi rl, right? So we actually can plug that in because we already know our radius is 4. So surface area equals 50.24 plus pi times r times l. 4 times 10 is 40. 40 times 3.14 is 125.6. So 50.24 plus 125.6 gives us 175.84 centimeters squared. Okay? Last one. Okay, this one's a little bit tricky. Okay. The reason why this one's tricky is because they're giving us the height of this cone and they're giving us an angle. So we need to figure out what our slant height is, and we also at the same time have to figure out what our radius is. And the only way to do that is we got to use trig. Okay? And so if I go ahead and I pull out this triangle, because notice if I use the height of the cone, the radius of the cone, and the slant height of the cone, I am making a right triangle. Okay? So I know this is 12, I know this angle is 56, and I need to find my slant height and my radius. So our focus angle is 56. That means our r, that's our adjacent. The 12 is our opposite, and the h is the l is our hypotenuse. So to find, I'm going to always be using the 12 here because it's a non-rounded length. So if I wanted to find a, 12 and a, that's opposite and adjacent, so that's tangent. So the tangent of 56 equals opposite over adjacent. The tangent of 56 and a change spots, so a equals 12 divided by tangent 56. Go ahead and use my calculator. 12 divided by tangent 56 gets me 8.1. Sorry, I shouldn't have put a. Technically, this is r, right? My fault. So R, our radius, is 8.1. I put A because I said that's the adjacent side, but I meant R. Okay, so let's go ahead and erase that. It should have been 12 over R. Okay, and then to find my slant height, that would be, I'm using the opposite and the hypotenuse, so that's sine. So the sine of 56 equals opposite over hypotenuse. Once again, those are going to have to exchange, so L equals 12 over sine 56. So 12 divided by sine 56, that's 14.5. Okay, so my slant height's 14.5, my radius is 8.1. That allows me to find all the missing information that I need. So my slant height, as we said, is 14.5. The area of my base is pi r squared. Okay, so 8.1 squared times 3.14 is 206. Let's go with just 206, actually. 206. And then we can do our formula. Surface area equals 206 plus pi times r, which again was 8.1, times my slant height. 14.5 times 8.1 times 3.14 gives us 368.8. So we get 206 plus 368.8 for a total surface area of 574.8 inches squared. Boom, all done.